Hello everyone, it's me again. In today's video, we are going to talk about some of the basic data types in Python. There are 4 commonly used basic data types, or primitive data types in Python. The first one is integer, which includes all of the whole numbers. Some examples include 0, 5, -6, or 5257, and so on. As long as it is a whole number, it doesn't matter whether it's positive or negative, whether it's small or large. It belongs to integers. The second data type is called float. Unlike integers, float represents numbers that have decimals. For example, 0.01 is a float data type. 5.0 is also a float data type because it has a decimal point. -5.28 and also 5257.66 are all float data type. The third data type is called Boolean. A Boolean data can only has 2 values, either true or false. Booleans are very commonly used. In today's video, we will use Booleans to indicate the relationship between 2 numbers. In the future videos, we will see some of its other applications. The last primitive data type is the string data type. String data type simply represents a string of characters. Essentially, all plain texts are string data type. Symbols and punctuations also belong to strings. For example, the $ and the question mark that I have in this example, do you have $10? Both of them belongs to string. String data type are enclosed by either 2 double quotes, one on each 2 sides, or 2 single quotes on either side. So either double quotes or single quotes will work in creating a string, and the choice is left to the programmers. We will talk about all the details in string data type in the next video. In today's video, we will just focus on the top 3, which are integers, float, and Boolean. Now let's launch a brand new Jupyter notebook to see some real examples. Right now I'm having a new Jupyter notebook which I name Python Tutorial 3 Primitive Data Types. The first thing I want to show you is the type function, which is a function that can check the data type of a value. For example, if I pass value number 5 into the type function and execute it by pressing shift and enter together, I will get an integer output, meaning that the value of number 5 is an integer data type. We can try different values as well. For example, 0 is also belongs to integer. If we try my negative numbers, let's say -500, which is also an integer. Another thing I want to show you is that you can actually store a value inside a variable. So for example, if I type x equals to 567 and execute it, that means I am storing 567 as a value inside a variable x. Now I can check the data type of variable x, which is an integer. So that's basically an integer. Let's try some float number and see what happens. So if I check the data type of 5.4, it says that this value is a float data type. Let's try some negative number. For example, -6.7, which is also a float data type. I want to show you an interesting example, which is 5.0. Now 5, although it's an integer, but as long as we add a decimal point, it will be treated as a float data type. So that's something to be aware of. Both integer and float are numbers. And the next thing I want to show you is some basic operations that we can perform on these numbers. First of all, we can do some basic arithmetic calculations. We can add 2 numbers together. Let's add 5 plus 6, which results in 11. We can also do subtractions. For example, 5 minus 6.2 it gave us a number minus 1.2. We can also do multiplications. So 3 multiplied by 4, that gives us 12. We can also do division. So for example, 9 divided by 1.2, the answer is 7.5. We can use parentheses to control the order of these operations. For example, if I say 5 plus 9 multiplied by 2, now because Python will execute the multiplication first before it executes the addition or subtraction. So 9 times 12 is 18 plus 5, that will give us 23. However, if you want to control the sequence of the operation and you want to ask Python to perform the addition first, you can enclose 5 plus 9 inside a parenthesis and then multiply by 2 afterward. Now if we execute it now, we will get a different answer, 28. And this is because 5 plus 9 is 14 and 14 times 2 is 28. Now if you want to raise a number to a power, you can use the exponential operator, which is represented by double asterisks. So for example, 2 double asterisks 6 means that we are raising 2 to the power of 6. Next, I want to introduce an operator called modulo, which is represented by a percent sign. For example, we can type 5 mod 2 and the output is 1. So what the modulo operator does is to perform the division and output only the remainder. The modulo operator is read as mod, so 5 mod 2 equals to 2 with a remainder of 1, and that is the reason the output is 1. Let's try another example. We can try, for example, 11 mod 4. The remainder is 3, so the output is 3. Let's say we don't want the remainder, we want the quotient instead. We can use the double backslashes to output the quotient. So for example, 11 double backslashes 4, it will give us the number 2 instead of a remainder 3. If you want to multiply a number with 10 raised to a power, you can use the lowercase e notation. So for example, let's say you want to calculate 2 times 10 raised to the power of 3. Now, 10 raised to the power of 3 is 1000. 2 times 1000 will give us 2000. We can do the same thing with this lowercase e notation that represents 10 raised to some power. So if we type 2e3, it's just exactly the same thing as 2 multiplied by 10 raised to the third power. So the output is 2000 as well. You can calculate the absolute value of a number by passing it to the obs function. So for example, absolute value of minus 5 is equals to 5. Absolute value of minus 50 is equals to 50. You can also round a value by passing the number to the round function. So for example, if we pass 5.2 inside the round function, the answer is 5. But if we type 5.9 inside the round function, the answer will be 6. Next, I want to talk about something called a math module. So math module provides more useful mathematical functions. To import the math module, we will need to type import math. So once we do that, we can utilize all the functions inside this math module. First thing I want to show you is the floor function, which is very similar to the round function, but it always rounds down to the smaller integer. For example, let's say math.floor, and if we pass the value 5.2, it will round down to number 5. However, if we do the same thing with 5.9, it will still round down to number 5. And the exact opposite of the floor function is the ceil function, CEIL. So for example, if we pass 5.2 to the CL function, we will get the number 6 because no matter what the decimal is, it will automatically round the value up to the next integer. So if we do CL 5.9, we will still get number 6. Math module has a square root function. To utilize that, we type math.sqrt, and if we pass 16 into the square root function, we will get number 4. Math modules also provide some useful constants. For example, we can use math.pi to obtain the value of pi. We can use math.e to obtain the base of natural log. There are many more useful functions in the math module, such as factorial, logarithmic functions, trigonometric functions, and so on. For people who are interested to learn more, I will leave the link to its official documentation in the description below. Next, I want to talk about how you can compare two numbers using what are called the relational operators. There are a total of 6 relational operators: equal to, which is represented by double equal signs; not equal to, which is represented by an exclamation mark and an equal sign; less than or equal to; greater than or equal to. These relational operators can be used to compare two numbers. For example, we can check whether 5 is equal to 6 by using 5 double equal sign 6, and the answer is false. We can also check whether 5 is less than 6, and the answer is true. Notice that we can store this value to a variable as well. So for example, let's say y is equal to 5 less than 6. Now, if we print the value of y, we will get the value of y is equals to true. And if we check the data type of y, we can see that the data type of y is a Boolean. Other than comparing two numbers, you can also create a Boolean data type by simply type true or false. For example, we can say L equals to true. Please capitalize the first character T. If you do it correctly, the color of true will turn green. Now L becomes a Boolean variable with value true. So let's check the data type of L, which is also a Boolean. We can also make, for example, variable k equals to false. Again, you need to make sure the first character F is capitalized. If you do it correctly, the color of false will turn green. And now if we check the data type of k, you can see that k is also a Boolean now. This pretty much covers all I want to say in this video. To quickly recap, in this video we introduced 3 of the Python primitive data types: integer, float, and Boolean. We talk about some basic operations on numbers, including the ones in the math module. Toward the end of the tutorial, we also talk about the 6 relational operators. In the next video, when we talk about string data type, we will see more examples of the Booleans. If you like this video, make sure to like the video and subscribe. Until next time.